In this section, we are going to talk about how do we represent real number on number line. We'll discuss about representing real numbers on number line. Then we'll talk about representing rational number on number line. We'll talk about representing irrational number on number line. We'll talk about representing irrational number on number line geometrically. And then we'll take a look of some examples. So let's start with representing real number on number lines. Any real number can be represented on number lines. Natural number n, which is counting numbers, can be represented on number lines as 1, 2, 3. When you extend this backwards towards 0, what you get is whole number. When you further extend it backwards to include negative numbers, what you get is integers. When you further insert fractions for which decimal values will either terminate or will repeat, what you get is rational numbers. Further, when you include all roots, what you get is irrational numbers. And at the end, when you fill all the numbers to make continuous line by including some of the values like e, pi minus e, and every bits and pieces on number lines to make it continuous, what you get is number line. Now let's talk about how will you represent rational number on number line. And in this example, we'll take terminating number. Represent a number 2.665 on number line. We know 2.665 lies between 2 and 3. If we magnify 2 and 3 and divide them into 10 parts, then we will notice 2.665 will lie between 2.6 and 2.7. Let's take a look. So this is my number 2 and 3. If I magnify this and then I get 2 and 3 and divide them into 10 parts, what I get is 2.1, 2.2, 2.3, 2.4, 2.5 is the middle section, 2.6, 2.7, 2.8, 2.9. And now you will notice 2.665 lies between 2.6 and 2.7. If we magnify this further and divide them into 10 parts, I'll get 2.6, 2.7 and the 10 division between them. We'll notice 2.665 is a number between 2.66 and 2.67. Here I have 2.66 and here I have 2.67. If we further divide that into 10 parts, the fifth mark on 2.66 and 2.67 is what gives you 2.665. Now let's represent rational number on number line, which is non-terminating numbers but recurring. Visualize the representation of 5.377777 up to 5 decimal places. We will proceed by successive magnification of successively decreasing the length of portion of the number line. First, we see that 5.3777 up to 5 digit is located between 5 and 6. In the next step, we locate 5.37777 between 5.3 and 5.4. In the next step, 5.37777 up to 5 terms lies between 5.37 and 5.38. And next, same lies between 5.377, 5.378, and at the end you will see it is closer to 5.3778 than to 5.3777. And here is how your picture representation look like. So we started with 5.3 and 5.4. Well, before that we started with 5 and 6. Then we magnify this between 5.3 and 5.4. Then we look 5.37 and 5.38. And when you further magnify this, you look a number of 5.377 and 5.378. And in this case, what you find, 5.37777 is much more closer to 5.3778 than to 5.3777. So between this and this, I'm going to keep this closer, and that represents me a recurring value for 5.37 recurring up to 5 digit. Now let's talk about representing irrational number on number line. Any irrational number can be represented on number line. Let's take an example of square root of 2 and see how we can represent it on the number line. In order for you to really find the value of a square root of 2, what you need to do is you draw a number line, go to the center, measure 1 unit from the center, which is OA, and then go perpendicularly up to 1 unit, which gives you AB, and then combine OB. What you get is square root of 2. Now you take your compass, put it at center O, which is origin, and go to B and draw it and see at what point it is intersecting with the number line. The point gives you square root value of 2 on the number lines. Similarly, we can show a square root of 3, 4, 5, 6, 7, 8, 9, and any square root on the number line as shown below. And here is an example of square root of 3. Again, you start with origin O, go 1 unit up to OA, and then go 1 unit perpendicular to OA, which is AB, and then you find the value of OB, which is square root of 2. Again, you consider OB as one axis and then draw a perpendicular line on it up to 1 unit, which is BD, and then combine them. Again, the value of OD will be square root of 3. Right? Because we know this is what OB square plus BD square will give you OD square. Right? So now take your compass, put it on O and D and draw it and see where it is intersecting your number line. That gives you a square root of 3. And similarly, if you have to find a square root of 4, 5, 6, 7, you keep extending perpendicular line and see where it is intersecting the real number line. And here are the examples, right? So you can go up to whatever number you want and keep following the similar pattern. This was a representation of irrational number. Now let's take a look. If I have to represent irrational number geometrically, how do I go about it? A square root of any positive real number, say x, can be represented as square root of x, and to represent them geometrically, we need to perform following steps. Step 1. Make a distance x unit from a fixed point, say A, on a given line to obtain a point B such that AB equal to x. Then from B, make a distance of 1 unit and mark the new point as C, such as AC equal to AB plus 1, and this is equal to x plus 1. And then find the midpoint of AC and mark this as origin, like O. And hence midpoint will be x plus 1 divided by 2, where OA equal to OC. Then draw a semicircle with center at O and radius as OC. And at the end, draw a line perpendicular to AC, passing through B. You will see the perpendicular line will cross semicircle at D, and then BD will show square root of x. Let's take how does it look. We started with A, and what we have done, we have gone from A to B up to x point, and then we extended B to C as 1 unit, and hence AC was x plus 1. And now we divided it to find O, which is center, and then from that center we draw a semicircle. Once we get a semicircle, we look the point B, which was x unit from A, and we draw a perpendicular line on top of it. The point where it is intersecting gives you point D on the semicircle, and in this case the length of BD will represent a square root of x. If you want to show a square root of x on number line, then extend line going through ABC. You got to extend this line further and then draw an arc by treating B as center and BD equal to square root of x as radius. So, and then you will see the arc will intersect the line E, which will represent under root x on the number line. Now let's try to recap it, right? What I'm trying to do. So if I have to find square root value of x on the number line itself, and assuming this is my number line passing through A, B and C, extend your line little further and then consider B as center, take BD as the length of an arc, and then use your compass and draw an arc and try to see where will it intersect the number line. And you will see it's going to intersect the number line somewhere at E, and that also represent the value of square root of x. Now this value of square root of x is value from point B. Represent any real number on number line. Here is an example. Locate 1 by square root of 2 on number line. In order to locate this, we'll try to simplify this first. 1 by square root of 2 can be represented as square root of 2 by 2, because you can multiply them with square root of 2 by 2, which gives you square root of 2 by 2. But what it gives me an indication of, in order to find me value of 1 by square root of 2, I first need to find the value of square root of 2 and then make it half, which is simple. I do the same way. I go and find the value of square root of 2, and then I'm going to divide it in half. That's going to give me the value of 1 by square root of 2. How do you represent 2 plus square root of 3 on number line? Well, let's take an example. In order to perform this, what you're going to do, you have to first find the value of square root of 3. And in order to find the value of square root of 3, since I have to find the value of 2 plus square root of 3, as opposed to 0, I'll move 2 units further, and I consider B as the point where I go 1 unit up to C and 1 unit perpendicular to C as CD, and then I'll calculate BD as a square root of 2, and then I'll go again perpendicular line on BD up to E as 1 unit, and then I'll calculate BE as a square root of 3. Now I'm going to use my compass and draw an arc, assuming BE is my length to draw the arc, and see where it intersects number line. In this case, this is intersecting at F. That value from B to F will give me square root of 3, and since I had a value from O to B as 2, my value of 2 plus square root of 3 is O to F. Thanks for watching. You can visit us on www.classisfun.com.